In the previous lesson, we started to figure out what that truck speaker is doing when it's actually making sound. It's vibrating back and forth from the rest position, and as it vibrates back and forth, it's making sound. Well, today, we're going to analyze the difference between when that speaker is making a loud sound versus when that speaker is making a soft sound. So, grab your pencil, your journal slip, your science journal, and you'll need this speaker simulation link that's posted on Schoology. Now here's a simulation that we're going to be using, and it's actually going to graph the motion of a speaker like the truck speaker when it's making sounds that we create by pressing keys on the piano. It's actually telling us how far back and forth it's moving when we play these different sounds. Pause the screencast, find the simulation link on Schoology so that you can navigate along with me. I'll give you a moment to get set up. All right, let's navigate out to the simulation. The first time you go to the simulation, you'll want to allow it access to your microphone. And you can see that when I press any key, a sound is being created. And then a graph is being produced on this screen. This is the rest position right here. So as the speaker is vibrating, it's moving away from the rest position, and you can see how far back and forth from the rest position it's moving. If I change any of these, I can make the graph square, sawtooth, triangle, but I like this one. This is the one you're probably most familiar seeing. And then later on, if you change to live input, you'll see that you see the graph showing up on my screen as a result of how the speakers are vibrating based on the sound of my voice being picked up. Okay, let's change it back to sine. And then let's investigate how this graph looks for a soft sound first. Bring the volume down to soft. We're going to press key number 6. And here it is showing you how far back and forth the speaker is vibrating from the rest position. Graph this on your journal slip. Okay, we're going to press that same key, but we're going to make the volume loud. Ready? Now graph this, showing you can hear that the sound is louder. This is how far back and forth the speaker is vibrating. Okay. So now look at the two graphs that you drew. What do you notice? Yeah, the graphs are really similar, but the softer sound, right? It's not as tall vertically as when I produce a louder sound. It's much taller vertically. Okay, I want you to do the next part of the simulation on your own. Follow all the directions on your journal slip, have some fun, and then we'll come back in a few moments and analyze. Go ahead and do this now. All right, you're back. Well, I've put an example of a graph for a soft sound on the screen and one for a loud sound. The dashed line also represents the rest or the starting position. So that's what you can see here. The first question I have for you is, did you notice any particular shape to the graph? Absolutely. There was an S shape or a wave shape on the graphs. But did you see any repeating pattern? Like, could you show me where the shape starts and where it ends? Okay, there is a repeating pattern. So I'm going to use this graph right down here of a loud sound. As the speaker starts to vibrate and it moves away from the rest position, it comes all the way up here, we call this a peak, and then it comes down, it hits the rest, and it goes under, this is a valley, comes back up to the rest, and then overshoots again to the next peak. From peak to peak, we call this a wavelength. From this peak to this peak, it repeats, it's a second wavelength. And this one to this one, it's repeating again, it's a third wavelength. We could also measure from valley to valley is a wavelength, or this valley to this valley is a wavelength. Now, what was the big difference between the graph of the speaker playing the loud versus the soft sound? Absolutely. It was the vertical distance of the graphs. The vertical distance was greater for loud sounds than it is for soft sounds. And so what does that really mean? How does that connect to our phenomenon of the truck speaker? Well, it means that when the speaker is vibrating back and forth from the rest position, if it's vibrating back and forth a really large distance, the sound that the speaker is producing is really loud. But if it's vibrating back and forth a smaller distance, then the sound is softer. Okay, so we're really pretty much figuring out what happens when a sound source is making sounds. We know it's vibrating, and now we know how it's vibrating when it's loud or soft. First, amplitude is the distance that we call distance from the starting position to a valley or to a peak, right? And so what we can see is that when the amplitude, when the distance is very great, the sound is very loud. And when the amplitude or the distance is lower, the sound is softer. Think about this for a minute. You know when you hit something really hard, like you hit a drum really hard, the sound is loud. And you can explain why. Because when you hit something really hard and you apply a great force, that drum skin really dips below its rest position. It really overshoots the rest position. The amplitude is really great and you hear a loud sound. But if you just tap the drum, then that drum skin doesn't move very far from the rest position. It doesn't move as great. The amplitude is much lower and the sound is much softer. I want you to continue thinking about loud versus soft sounds. Today, submit your journal slip and continue to apply these ideas as you complete a Google form about loud and soft sounds. Until tomorrow, keep thinking, keep learning, and we're going to investigate something different tomorrow: pitch.